All right.
Okay, let's go. Let's trace out and label some of these components. You need to draw this as best you can. In fact, have you guys already started drawing this, or you're electrical?
Electrical.
Okay, I'm going to give you special paper to work on this.
Oh,
all right. Here's your discharge line. It comes out here, and it comes around to our oil separator. The hot gas goes through here and comes out. The oil piles up on the bottom. It comes back on this oil return line right here. You loop around here. A lot of times, though, they'll put a loop like right here, which they kind of have, and maybe a loop right here to deal with noise and vibration and expansion, contraction of the copper, because it gets really hot here, and these semi-hermetics tend to vibrate quite a bit. So this doesn't have a vibration eliminator on the discharge line, so sometimes they loop the pipe around to give it some movement cushion. You come out the discharge line, you come out the bottom, which is the liquid line, into our receiver. You come out the receiver here on the liquid line. You come around, you go to our sight glass. You come out of the sight glass, you go through a liquid line filter dryer, you come up, you come over, you go into the back of the box. When you go inside the back of the box, you're going to see that it goes through a liquid line solenoid valve. The liquid line solenoid valve is part of the pump down process. And then once it goes through the liquid line solenoid valve, it's going through a thermostatic expansion valve. It goes through the evaporator, boils off, and comes back on this insulated suction line. It comes to our CPR valve, which is our crankcase pressure regulating valve, which can be adjusted here. This limits the amount of refrigerant going back to the compressor during the hot pull down. This freezer is designed to maintain 0 degrees. Right now, the freezer inside is probably 65 degrees. That's way too much heat energy for this machine to handle. This holds back some of the refrigerant, and it limits the amount of maximum pressure that comes out of here. By limiting the flow, it limits the amps. You can set this based on what your ammeter says there. And this will come into play for maybe the first 25 minutes or something. And then once the box gets kind of close down to temperature a little bit, this isn't really a factor anymore. Okay? And I think this is about 35 pounds actually that this is set at. The one in the book was 5. It comes through here, you go to your accumulator. You come here through the vibration eliminator back into the compressor. Looking at the diagram here, we see that we can start with the thermostat. On the back of this box, there's a thermostat inside. When the temperature is too warm, which could be anything above 0, this is going to close, energize our liquid line solenoid valve. When that energizes, liquid refrigerant is going to flow to the low side. Come down here, the pressure is going to build up, and this pressure switch is going to close and say it's okay to turn the compressor on. But when that happens, this low pressure control closes, and the contactor coil pulls in right there. Here's the coil. It gets energy. It pulls in the contacts, which I just depressed. When that happens, the contacts close here and here, and the compressor runs, and one of the condenser fan motors starts. And the machine will run for a little while, and then if it's a bit warm like it is in here now, this fan cycling pressure control will close, bring on the second fan. And that is this one. Okay? So when this closes, then you have both of them running. If it was really, really cold in here, this may never come on. The machine's going to run and run and run and get colder and colder and colder, and till the box says it's cold enough, which is below 0. Then what happens is the thermostat opens up, the liquid line solenoid closes. The compressor keeps running and it sucks all the refrigerant out of the low side and piles it up in our receiver and our condenser. And the pressure drops down to around 0, 2 or 3 pounds, it really doesn't matter. And once it gets below that, the low pressure control here is going to open up. This opens up, it kills power to our contactor coil. The contacts de-energize, this opens up, this opens up. The compressor and both condenser fans shut off. And the unit stays off until there's a call for cooling. Now when we go into defrost, which in this case is 4 times a day, you have this defrost time clock here. Each pin, this circle represents 24 hours. Each pin represents a defrost. We're going to defrost every 6 hours. And this is going to turn, and that's staying freezing, freezing, freezing. Then it gets to the pin, and when it clicks, it goes into defrost right there. And when it hits that pin and goes into defrost, what happens is this contact opens up. And it's very similar to opening up the thermostat. When this opens up, it kills power to liquid line solenoid, it pumps down, it shuts off on low pressure. However, since we're going into defrost, not only are we shutting off the compressor and the condenser fan, we're also shutting off the evaporator fans inside, because when we go into defrost, we don't want to blow that heat around the box. We want the heat to melt the ice.
Right.
When this opens, this closes, this defrost time clock contact. This closes, it energizes this motor starter coil or mag starter coil right here, and it allows power to, it closes its contacts, and then it powers up the defrost heaters. These are some black heaters you'll see embedded in the evaporator coil inside, and you can go in there and look at them. And then the defrost heaters are going to come on and melt the ice. Okay? After, how long do we stay in defrost? Well, this time clock says
30 seconds.
30 minutes.
30 minutes.
So here, after 30 minutes, it clicks back. When it clicks back, this is going to open up, kill power to here, and the defrost heaters are going to shut off. At the same time, this is going to close, and then definitely our thermostat should be closed, because we just add a lot of heat to that box with the heaters, so it's going to be closed. The liquid line solenoid is going to energize, our low pressure control is going to close, our contactor coil is going to energize, and we're going to go back into the freezing cycle. If you want to adjust the time for defrost, you can push this pin in like that to, let's say, 20 minutes. Or if you say, I don't need to defrost this 4 times a day, I want to defrost it 3, you could remove a pin and then move the pins to every 8 hours, and then you could defrost it every 8 hours by moving these around to every 8 hours. So you could defrost it a little bit less if you want. Okay? So you can adjust with these pins the number of times a day it defrosts, and then with that little pin, the length. Most of the systems out there, really all of the systems out there, have a defrost termination thermostat where if all the ice is gone, it's going to take it out of defrost immediately, right? This system doesn't, which is good for us, because if that was the case, the only way we could actually test it in defrost would be to run it for like 4 or 5 hours first. It's very noisy, and we'd never get to see a defrost, because it would go defrost right back out. It wouldn't even go into defrost, because the coil would have to build up a block of ice first. So by just going off of time, you guys actually get to see what happens during defrost. Okay? Any questions?
Sensei.
Awesome.
You see, it's better to do this than have. It's hard. It's a little crowded with 12 guys. 30 guys is not going to work.
I don't believe it. Did anyone write down on the nameplate? No.
So okay, you guys are ready to be turned on now. We got a lot going on here. Got your hand here?
Did you take
There's already
Pressure. The unit.
How are you? Little Mermaid.
Little Mermaid.
LA.
Little Mermaid. Hey, yo, Little Mermaid.
Oh wait, let me give you guys some paper. I'm going to give you some paper. I want a special drawing on this one.
See the compressor. The compressor will be right here on the right knee.
That's the main area. That's his last name.
Yeah.
We'll get the compressor right here, right? Right here. Oh, here.
Here. Try this. It's going to take you a while.